Okay, so for this second lesson, we are talking about function notations. So it's not so much, we will be evaluating functions, but instead of just determining if it is a function or not by giving a table, ordered pair, graph, or mapping situation, we're actually given a function and we need to we're given an input and finding an output. So instead of actually looking and determining if it's a function or not, we are actually looking at getting an input and finding an output. So let's go over some basic vocabulary. So let's talk about evaluate. Evaluate is to process something, to think about something. When you want to evaluate something, you study it, right? So if we want to evaluate a function, we need to, one, look at it, and we need to determine the pieces of inputs and what are we going to get for an output. So we're not actually going to write the vocabulary for evaluate and a few other ones because they're just common terms that we hear every day. It's just not specific to function notations. So function notation, we're talking about f of x, which is most commonly going to be shown. F of x equals, you know, are the equation or the expression out here. So let's say 2x. This would be like a function notation. There's parent notations or parent functions that we'll probably get into, but here means this is a function of x. Here's my input. So if I were to say, I want to know what f of 3 is, f of x with 3 as my input. Well, this just means that this is my input, and here's my input right there. So really all I'm doing is just 2 times 3. So if my input is 3, well, my answer is going, or my output is going to be 6, because this right here is 2 times x, and the function f of x, when I want an input of 3, all I need to do is plug that 3 in for the x and just go on with my operations. Domain and range, input, output, we've talked before. Here's x's, here's my y's, here's my y's. Input and domain give me my output and range. Same thing with independent and dependent. If you're still having a little bit of trouble, if I'm going a little too quick, go to yesterday's lesson, go to that video that's going to be linked into your journal or the Nearpod that your teacher has. Go in there and you're going to get the basic information. We've talked about it. We don't need to go too in depth with it. An element of and corresponding, it's just things that work together. And being an element of something, that just means you're a part of something, and corresponding means you work with something. So let's go ahead and go into our I do. So a metallurgist determined the monthly profit in dollars for commissioning in number of pieces using P of n equals 49 n minus 0.15 n to the second power. What is a monthly profit if the metallurgist commissions 18 pieces? Well, we know in, well, let's actually go through and let's do our cubes method, right? So we're going to circle, underline, box, eliminate, and then solve. So first we want to circle our numbers, right? So we know this is really big right here, 18 pieces. And let's go ahead and just circle this because there are numbers attached to it. Let's just go ahead and circle that whole function. We're going to underline the question, right? So let's do that in red. What is the monthly profit if the metallurgist commissions 18 pieces? Let's box important words in green. So what's really important here is we're commissioning in number of pieces. So that tells me n equals number of pieces. And how is that going to help? Well, if we underlined our question. Our question is, what is the profit of the metallurgist of 18 pieces? So we want to know, we already know in right here, we know in right here, and here are going to be the number of pieces, and we already know that number is going to be 18. And then eliminate, we're not going to go through and eliminate. Everything here looks pretty good. There's not any numbers that are confusing you that are throwing this off. And let's just go ahead and solve. So I'm going to actually write my function over here, P of n equals 49n. Now I'm going to actually write the n in here, but you're going to see me erase it here in a second because I'm actually going to get the corresponding value for it, the number that we're going to sub, because we already know that number. So we're going to go ahead and there's my function. Well, let's go back over here. And we already know n is the number of pieces. Well, in the question, remember, they told us how many pieces they wanted. They wanted 18 pieces. So I know here n is going to be 18. Another way to write that is f of 18. So we want to know what the function is when our input is 18. So you see how n equals 18, f of, or I'm sorry, in here in this term, I'm sorry, I'm actually going to erase this because I don't want you to get confused. Here it's p of n. So p of n, p of 18. This is going to be our input right here. So I'm actually going to erase the n because we know what n is going to be to solve for this. We're going to plug in the number 18. I'm just going to do it in purple because I've been kind of switching colors, green and red, and I don't want you to automatically think green and red is input output. So here I'm going to put 18 and 18. And then from here, this is just a basic math question, basic computation. So we're going to have to know our order of operations. You should know PEMDAS. I don't really teach it like PEMDAS because I don't want you to automatically think that multiplication always goes before division. Remember, we read left to right in any type of function. So given our order of operations. So I know with order of operations, I need to do my exponent first. So this means 18 squared. So I'm just going to bring this down over here. Well, 18 squared, I'm sorry, let me actually do it like this. 18 squared, remember, is just 18 times 18. If you go ahead and use your calculator for that, 18 times 18 is 324. So now that we have that, I'm just going to kind of rewrite my function. It is going to be a lot of writing, but it's going to be easier to see. So I'm just going to rewrite my function. And I'm actually going to solve for this part first because now, again, we're still doing order of operations. So I'm just going to do it from left to right. So 49 times 18 is 882. So here, 882 equals P of n. So we have, we brought down our function by doing our computation. So remember putting that 18 in for n, the letter n, our variable n, and bringing it down. Now, let's continue to solve. So still doing order of operations, I still have a multiplication before I can do my subtraction. And that multiplication is 0.5, or 0.15, I'm sorry, multiplied by 324. So if you go ahead and put that in your calculator, 0.15 times 324 is 48.6. 48.6. Here's our subtraction. And then we still have our 882. And just still writing this. Now again, you can also put the number 18 in here. That's not going to do anything. That's how it's usually going to look. Sorry, I didn't put that in at the beginning. I forgot to actually erase that in and put that in there. But yeah, you don't have to have that in there. You'll most likely see that 18 in that input area for our function. And then from here, let's just do our basic subtraction. And I'm just going to go from left to right. I'm not going to bring it down anymore because I'm running out a little bit of real estate. 882 minus 48.6 is 833.4. So I'm going to circle that. I'm going to bring that over here. So what is the monthly profit? The monthly profit, profit is money. Our answer is going to be, I'm sorry, he's going to make, or this metallurgist is going to make $833.40 for the monthly profit. Now, why did I put that zero there? Because we're talking about money. So that's why I added in there. I know that's cents. Zero point 0.4 is 40 cents. So that's why I threw it in there like that. Yes, this is the answer, but remember that zero isn't going to affect it. And it looks as if it is a monthly profit. So with function notations, really all you're doing is getting that input and finding an output. So you're subbing in a number for the variable in our function, and we are just doing computation. We're just doing addition, multiplication, subtraction, parentheses, exponents. We're doing the array of computations that the function will make us do. Um, you'll see it a little bit differently tomorrow, given two functions. So go slowly. This is the first time you're seeing us actually have inputs and then finding an output. So actually having a specific quantity and using that in a function notation and getting out an output. So work with it slowly. If you have any questions, we'll be doing the we do's together. But after that, um, feel free to ask your teacher if you need any more assistance.